Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. The largest asteroid in the asteroid belt, Ceres. Ceres is the largest asteroid in the main asteroid belt. It is 580 miles in diameter, having a transient atmosphere of water vapor derived from exposed surface ice evaporated by the sun. Ceres composition is a mixture of water ice and hydrated minerals such as carbonates and clay. Ceres possesses a partially differentiated muddy ice rock mantle core and a less dense but stronger crust that is 30% ice by volume. Overall, a quarter of Ceres' mass composition is made up of water ice. If Ceres ever possessed any internal ocean of liquid water, it has frozen long ago. However, Ceres is not completely frozen. Brine water still flows through the outer mantle and reaches the surface. This process allows for the formation of cryovolcanoes, such as Ahuna Mons, to form. Cryovolcanoes form on Ceres at the rate of 1 every 50 million years. Due to the presence of clay minerals makes Ceres composition similar to carbonaceous chondrite meteorites. Graphite, sulfur, and sulfur dioxide are present on Ceres' surface. The graphite is a result of space weathering on Ceres' older surfaces. The sulfur and sulfur dioxide are volatiles formed under Ceres geological processes, with certain amounts dissipating quickly and the rest in cold traps on Ceres' surface. These volatiles are associated with areas of relatively recent geological activity on Ceres. Most of Ceres' surface is also rich in carbon, being 20% by mass. This surface carbon has mixed with products of rock-water interactions such as clays. This chemistry suggests Ceres formed in a cold environment, perhaps outside the orbit of Jupiter, billions of years ago, accreting from ultra-carbon-rich materials in the presence of water, which could provide conditions favorable to organic chemistry. The Dawn space probe revealed Ceres has a heavily cratered surface. The largest confirmed crater on Ceres is Kirwan Basin, 176 miles across. Viscous relaxation of the crust slowly flattened out this large impact. Ceres' North Polar region shows far more cratering than the equatorial region, with the eastern equatorial region in particular comparatively lightly cratered. The overall size frequency of craters is 10 to 60 miles in diameter, having originated in the late heavy bombardment period. Craters outside Ceres' polar regions were erased by early cryovolcanism. 3 large shallow basins on Ceres with degraded rims are likely to be eroded craters. The largest, Vendemia Planitia, at 500 miles across. It is also the largest single geographical feature on Ceres. Ceres' prominent mountain, Ahuna Mons, is a cryovolcano with an age of 240 million years. It is dense and composed of rock and ice due to a slurry of brine and silicate particles from the top of the mantle. Ahuna Mons is roughly antipodal to Kirwan Basin, due to seismic energy from the Kirwan impact focused on the opposite side of Ceres. The fracturing of the outer layers of Ceres' crust facilitated the movement of high-viscosity cryomagma, consisting of muddy water ice softened by its content of salts, onto the surface. Kirwan itself displays evidence of the effects of liquid water due to impact melting of subsurface ice. Yamor Mons, an impact-cratered peak, resembles Ahuna Mons despite being much older, due to its lying in Ceres' northern polar region, where colder temperatures prevent viscous relaxation of the crust. Over the past billion years, 1 cryovolcano forms on Ceres, on average every 50 million years. The Dawn space probe observed 4,423 boulders larger than 344 feet in diameter on the surface of Ceres. These boulders likely formed through impacts, and thus are found within or near craters, though not all craters on Ceres contain boulders. Large boulders are more numerous at higher latitudes. Boulders on Ceres are brittle and degrade rapidly due to thermal stress, because at dawn and dusk, with the surface temperatures on Ceres changing rapidly. Also, meteoric impacts have a direct effect on boulder degradation as well. The maximum age of the boulders on Ceres is calculated to be 150 million years in age. Ceres is a water-rich body with a deep reservoir of brine that percolates to the surface, then crystallizing in hundreds of locations, causing bright spots to appear on its surface. The active geology of Ceres is driven by a combination of ice and brines. Altogether, Ceres is approximately 50% water by volume, 73% rock by mass. Ceres craters being 200 miles in diameter indicates that the outermost layer of Ceres is roughly 1,000 times stronger than water ice. Ceres has become considerably less geologically active over time, with a surface dominated by impact craters. Nevertheless, internal processes have continued to sculpt Ceres' surface to a significant extent. These internal processes that continue to sculpt Ceres' surface is contrary to planetary geologists' previous expectations that Ceres would have become geologically dead early in its history due to its small size. I hope you liked this short essay on the geology of Ceres. Thank you for watching.